Well, hi and welcome to my shop, and thanks for joining me here on December 30th. December 30th. Oh my gosh, 2021's almost over. Farewell to that. And what about this radio? So, just a quick recap. I'm looking primarily for the cause of distortion in the radio. In the course of changing the last few capacitors, things changed in the operation of the radio, and it appears to also have become weak. It appears to me to be an additional difficulty in the radio, so now I'm thinking there must be two things going on in this radio. Not necessarily so, but it could be. I've been sort of eliminating side issues and other things that might have a bearing on this. A couple of things I needed doing, and I've done them. Tested all the tubes. At this point, I'm really at quite a loss as to why the radio is not operating. I really don't know what has happened. I'm suspicious it's me. Often in these cases, it is me. I've done something wrong, done something stupid, or did something I didn't realize, or whatever it might be. I haven't found that thing yet. I've reviewed quite a number of the capacitors that I've installed to verify they're in the right positions. They are, but not all of them. So I did do some testing with a signal tracer. And what I did was I listened for the signal basically coming out of the IF right here. Although on my schematic it shows that signal being applied to pin 6. In this radio it's actually applied to pin 5. Doesn't make much difference. I don't think it makes any difference. They're both diode for two diodes inside this tube. The last video I got distracted by the low B plus on this tube. You know, the B plus shouldn't really be influencing the diode operation in the tube. I'm not 100% sure about that. And so I ended up replacing which resistor? This one right here. It turned into a bit of a schmozza when I made a mistake and stuck a 220 ohm resistor in instead of a 220,000 ohm resistor, which is out by a factor of 1,000. Radio was not happy about that at all. Didn't even operate. But I fixed that up, and we're back to the situation where it has a weak output and it's distorted at the same time. I did take the signal tracer. I didn't quite finish that thought. I listened here, loud and clear output of the IF. What seemed to be loud and clear output of the IF. You know, my signal tracer has its own volume control and whatnot. I could be fooled by it. I could use the signal tracer in such a way as to convince myself there's a strong signal here when there actually isn't. But I don't think that's what happened. So I'm going on the idea that the strong signal here, for some reason, cannot make it to the volume control, which is right here. How can it be strong here and not be strong down here? So those are interesting. That's an interesting question. I'm sure there's more questions coming too, so that's why I pluralize that in advance. What could be going on here? That's a good question. I think I need to poke around more, perhaps with the signal tracer. I was monitoring the AVC voltage earlier. It seemed to be kind of resolved and working properly, but I haven't looked at it since. Take that back. I think I remember after changing the last capacitors, the AVC voltage remained higher than it should under all circumstances. I remember thinking, well, maybe there's an oscillation coming through here, and the oscillation is at a frequency it cannot, we cannot hear it. It's not causing an audible effect, but it's causing a voltage at the diodes. Not sure about most. I'm really not sure about any of this. Lots of question marks after everything still. So maybe we got to go back and just repeat a few things. Maybe starting with that signal tracing. Yeah, that's a really good idea. Why don't we do that? This radio was able to pick up one station here in my shop, which is typical of radios in my shop, in my house. Mostly because the radio signals are down here and the noise signals are way up here, and they're just covering all the radio stations here in my shop. Did I mention the power was out for half an hour a few days ago, and I got a chance to turn on an AM radio, and it almost left me crying at the end. In the middle of the afternoon, I was able to pick up about a dozen stations. Those would all be just ground wave. They'd be there every day. They'd be there today, right now. All 12 of those stations are there to be heard. But power's on, computer's running, and the noise just washes everything out. What a shame. Okay, not to lament about the modern world, because that noise is mostly computers working, and they've improved our lives so immeasurably. It kind of makes me laugh when people talk about inflation and things like that. Yeah, sure, okay, cost of some things is going up, but at the same time, the world we live in is getting so much better, so much faster. And stuff that used to cost, like electronic equipment that used to cost tens of thousands of dollars, and now hundreds, putting tremendous power in our hands, and the internet and all that stuff. So we're all much more wealthy than we realize. I think that's the bottom line. With that happy thought in mind, I'm going to get ready to do a little bit of signal tracing, just to retrace some of my tracing steps, and just verify the situation in this radio. Okay, just before I get going, I'm feeling a little philosophical this morning, and part of that is because of a video I watched by a guy who makes very interesting videos, well worth watching. His YouTube channel is called Veritasium. If you're watching my kind of stuff, you've probably seen his videos, and most of them are very, very interesting, and he has an interesting way of presenting things. Well, he did a video on how energy moves in electric circuits, and his circuit, as a thought experiment, is a switch and a light bulb and a battery, and very, very, very long wires going from the battery and the switch to the light bulb. Then he makes the argument that the energy in the battery makes it to the light not by traveling through the wires, but by traveling straight through space from the battery to the light. Well, that's a pretty dramatic statement. There's a lot of problems with it, I believe. And since then I have watched at least half a dozen other video makers, serious thinkers about this kind of stuff, make videos and try to provide counter arguments or alternate ways of understanding what the Veritasium guy was putting forward. And I've watched them, and I suggest they're all wrong. They're all wrong. I just love this stuff. I love thinking about this stuff. So I'm not going to go into my own ideas about it, but I should make a video of my own. And just in case, because if you're watching these videos, you probably watched this Veritasium video already. And you've probably watched some of the other videos just like me. And you're probably scratching your head about just what exactly is going on. Look, in my world, in my personal world, okay, these are just two little magnets here. Just two magnets. And they happen to be the same pole, so they push. So I'm feeling the push here. I'm feeling the push. What is that? What is in between these two things that is pushing? Why is it they don't want to occupy the same space? Look at the distance there. I mean, this is ordinary. As little children were given magnets to play with. I certainly was. I felt this. Oh yeah, okay, and if you turn it around, it sticks. This one won't stick because the magnet's just a little one up in here. And then we kind of put it away, child's toys, and go on with life. Well, it never went away from me. Yeah, why is it when we put our hands together, they don't pass through each other? We go, well, they're in contact. Look at them. They're in contact. They're in the same contact that those magnets are in contact when I was pushing them together. It's the same kind of thing. Maybe this is an electric charge, and that is a magnetic effect. Nobody really knows exactly what these things are. Yes, there's a ton of mathematics to explain them, to predict them, but as for what exactly it is, I don't think anybody's got any notion whatsoever what these things really are. There we go. I love that. I love living in a world of mystery. That's why I like fixing these radios when they don't work. It's a big mystery. I also, personally, I have the sense that I'm playing around with part of the universe which isn't supposed to be accessible to life, or has never been accessible to life on this planet until we came along as human beings. And we've come up with all these mental models to explain things we're seeing and to raise questions. That's really what it's all about, is raising the right questions and then searching for the answers, which usually give you a whole bunch more questions to ask. And that's kind of the road we're traveling down. It's a little like troubleshooting, isn't it? A little like everything, really. Anyway, I'm feeling very philosophical today. Let's get to work. I'll turn on this radio. I think I'm going to turn on my meter here. Let's get the radio going. Here we go. Get my signal tracer going over here. It's over this way. Move the light. Okay. What I would like to do with the voltmeter is keep... Now there it is again. The radio operated, but as the voltages built up to where they're going, the operation faded out. This has to be the ABC voltage doing this, because I say so. Let's find out. Let's find out what's going on here. Now, where was I picking up the ABC? I was picking it up between the two big resistors. That's right in here. That was the click of the discharging of this piece of wire, which was charged up. See if I just charged it. No. Piece of wire holding a charge. Okay. See, I'm really in that mood today. Every little thing is going to fascinate me. Just as it should. The interesting thing about playing around with this analog technology, like this, as opposed to digital technology, is the analog technology is dealing with real stuff. Electricity and mechanical stuff. It's all extremely real. When you flip into the digital world, yeah, all that electronics is still there and that's all very real. But what you start dealing with as a human being is the information, which is why they call it information technology. You become interested in the information and less interested in what's behind it all, what's behind the scenes. So if you think about that, the digital world with the binary numbers and all that, it's really a manipulation of concepts and ideas and thoughts. And this is not doing that. This is not doing that. This is getting something stuck onto its antenna and it's making the speaker move, whether it likes it or not. There's no thinking going on in here of any sort whatsoever, no calculating. Not really. Not like in a computer, in the digital world. So that's interesting to me. Information free, although we get information out of it, don't we? I mean, we listen to the guy talk, he tells you the weather, now you know the temperature, you got some information. There's no doubt information can come through it. Same thing with a computer, in that sense. But in a computer, what we are doing as human beings is really paying attention to information. I guess like everything, nothing is totally separate, right? Everything is kind of missable to some degree. Oh my gosh, I'm really. Is it because I'm ahead on the coffee this morning? Well, what is it? Okay, this guy's warmed up. You know what it is? I hadn't been in the shop very much. Haven't been talking into my video microphone very much. Let's tune this radio and find out what's going on. Okay, so the volume's up quite a bit. Just check the frequency. Hey, what's wrong with this radio? Nothing. Why do I think something's wrong with it? That sounds pretty good, actually, for a radio in my shop. Well, let's carry on with this measurement over here. Okay. On the voltmeter, we are seeing an upscale reading, but the meter is set for minus. So this is a negative voltage, relative to things over here. And we're on the 5 volt scale, so this is actually a small voltage of 3 volts. So as I tune the radio in one direction, it's just going up and up. This is not the proper behavior at all. Let's put it on a higher scale. We'll tune it in that station. See if we can see the effect of the station. Not in the least. ABC voltage is misbehaving completely. So there's no way you can say this radio is operating okay. It certainly isn't. So I still think the output is low from what it should be. What's going on? So we'll get the signal tracer here. Now it's set to audio. Okay. We wanted to pick off, redo what I did the other day. I want to pick the signal off right up in here. So that'll be on pin 5, contrary to this diagram. That's right, pin 5. So counting. 1, 2, 3, 4, 5. 5, that's right, 5 is going straight to one of the IF. Guys, I'm going to turn this down a little bit. One of the IF transformers. Turn this down a bit. Just a little awkward here. Okay. That's not very good. Thought we heard a lot of stuff out of it last time. Definitely on audio. No question about it. Oh, well, maybe that's the problem, because at this point, so I'm touching it right up here, would you get audio there? I think the answer is yeah, you could. We're not. Let's make this have some program stuff coming out of it. Okay. Do we hear that coming out of it? Now I got it. Hold still there, mister. answer is yes, very faintly, just like the radio. Just like the radio. So I'm hearing on the signal tracer the same thing the radio's hearing. Weak output is what it sounds. It sounds like weak output from here now. So we jump back one tube and try to listen to what's coming out of here. That's on pin 1 of the 6BA6. Pin 1 of the 6BA6. Okay, let's take a look. See? Pin 1 of the 6BA6. So that tube is located right here. Pin 1 is easily spotted. Pin 1 is connected directly to an IF. Does that add up? Yes, it does. Pin 1 straight to an IF. Okay. Now listen to that. And we're not getting any program material because I rotated the radio, but let's listen anyway. Okay, volume over here. Pretty darn quiet. Very little. Very little. So if that's true, then it's a weak coming out of here. Wow, we're getting right back to here. Okay, ABC voltage is low, I think. 3 volts still. 3 volts shouldn't quiet down the radio. It should take like 10 or 12 or much more, yeah. I'll go back another step. We could listen to what's coming out on pin 5 from the 12BE6, which is going into this. I'm not sure what we would hear here. You know what? I just realized that I'm doing a boo-boo. Doing a boo-boo. Hold it. Boo-boo's being made. I have to flip this to RF. I'm going to try this again. Now, this is a signal tracer when it's in RF mode is a radio. It has a detector in it. So if I put this onto a modulated RF signal, there's a chance we'll hear whatever the modulation is, because it's a radio too. So let's go back. Let's go back and listen to this point up here on pin 5. Pin 5. Okay, pin 5 right here. So that's the output RF wise. There's a ton of it. So it kind of brings us right back to what about why is it not being detected properly in here? There's a ton of RF coming out here heading for the diode. Should produce a ton of audio. I think I'm going to have to put a signal generator on this, so it's a little more convenient to continue working. Yeah, I think I'm going to do that next. I'm going to set up a signal generator and carry on from there. Okay, so this is a very simple radio, and the volume control is right here, and there's not much going on. It's straight from the secondary side of this IF coil and the detector diode straight to the top, and it's straight from the bottom right down to B minus. There's no complicating factors in here. There's no extra resistors. There's nothing funny going on. There's no capacitors. Well, there's this one. There's this one. So why don't we listen to the very top of this. This should be exactly the same as getting onto. Should be the same. Let's do it. I'm going to put a clip on, in fact. What is that? Okay, just a little tricky to get it right to the right spot. Can't get at it. To move a wire. Radio is operating while I'm doing that. Okay, if I can get the clip in now. Really no dangerous voltages in a properly working radio there. Okay, I'll clip it on here. So now the signal tracer, I'm going to flip it back to audio. That's what it's hearing. It's hard to believe. So this sound should be coming out of here. Audio, definitely. Bad clip lead? Bad clip lead? Would that be the case? It's not even making contact there. So that sounds normal. Other end of this clip lead should sound exactly like that. It does. Okay, what's going on? I don't know. Mysteries abound. Is that a cold solder joint that I just affected? Just turn down the tracer. Okay, we'll tune in. Oh, I was going to get the signal generator going, wasn't I? I didn't. Let's do that. Let's get that signal generator going here. I'm going to use the output of the signal generator to transmit through a coil here. Oh, not this one. We'll use this. I'm just going to hang this back here, like so. The radio is tuned to roughly, it's right around 5. Okay, that's out of the radio speaker. That's out of my tracer. Thanks, sounds better. Sounds different, not necessarily better. Okay, so what's the problem with the radio now? What is the problem? So I'm energizing the feed coil here with a moderately strong signal. Very closely coupled. Volume is a fair bit of volume there. Oh, AVC voltage, what's it doing? Okay, so now I'm going to be able to really check this properly. Going to increase, let me turn up the radio a bit, increase the signal from the signal generator. No signal at all yields 3 volts. No signal at all yields 3 volts. And that voltage changes as you tune the radio. That's got to be the main hint right there. You know, what could do that? What could cause this effect? Again, more or less overwhelming the AVC voltage generated by regular signals. What could be going on with this radio? Some kind of leak of voltage. The only place there's a negative voltage in this radio to push this meter up in the direction it's going is out of these diodes. Diode. So the diode they're not using, they have simply tied it straight to B minus just to kind of get it out of there. So it's not doing anything. Cathode is right to B minus. So the other, just like any radio. This capacitor has failed here. It's a mica capacitor. So what would happen if that capacitor is not there? I think the job of this capacitor is to provide an RF ground at this point here. If you didn't do that, you'd have RF just flying down this part of the radio, flying back this way. But what we're seeing over here, because we're monitoring the AVC at this point, is a fairly steady voltage based on where you've tuned the radio. Could it be something like the local oscillator? Oh, this is such a reach. The local oscillator is somehow presenting itself all the way through here and showing up over here, and that's what's being rectified. And as you tune the radio, you're varying the frequency of the local oscillator, and so you're varying the amount that's making it out. Well, how could that happen? The local oscillator should be rejected by the IF transformers because it's running quite a distance from 455. The local oscillator somehow bypassing all of that, and the local oscillator be coming back this way, getting rectified here and then coming back as a DC result. Oh, I just killed a local oscillator and see if that voltage disappears. So to do that, radios. To do that, I think the easiest way, considering I'm staring into the back of it, figure out where all this is. Just want to put a ground right here. That might be just a little hard to spell. Well, I could put a ground on pin 1. ground on pin 1 of the 12BE6 will knock out the local oscillator. Put a ground on pin 1 of the 12BE6. Okay, so the 12BE6. Good show. There's a diagram here to save me from myself. Yeah, it's this tube here. That's this tube here. Putting a ground on means using this, not using the chassis. We're going to put a ground on. Okay, so I'm going to keep an eye on this meter during this. Pin 1, right? Triple checking. Yes, pin 1. Putting a ground on the wrong thing is kind of a painful deal. Pin 1. So I see a pin 1 here. Oh, that's not pin 1. That's not pin 1 there. There's pin 1. Okay, what happens? Oh, yeah, that's good spot there. Goes up. Yeah, what I'm doing, I'm trying to ground out the. Well, that certainly didn't ground out anything. So it's a lousy clip lead. That did not do the trick at all. I'm trying to get a clip lead here. That theory really went down the drain. So what I'm actually doing is I'm injecting a bunch of noise, because I'm above this resistor here. I think that's probably the problem. I need to be on the other side of this resistor. I would normally be putting it over here. Well, yeah, on the other side of this capacitor. Other side of the capacitor. Other side of the capacitor. Let's try that. That's way down here. Nope. So is my theory all wrong here? Am I just totally washed up? I'm essentially trying to short out this capacitor. Oh. Yes, everything is tied to the chassis here. Not to B minus. Not to B minus, to chassis. Okay, again, this is an aspect of these radios I don't fully understand why this is done. Now let's see if this will knock things out. Okay, we'll try either side. There we go. Look at that. And we go to the other side. Okay, we're injecting a little bit of noise there. That's the wrong spot. We're better off up here. So is that proof then? The local oscillator is coming through and being coming through. Now, how can that be? So what comes out of the top of this tube on the plate is a number of signals. Basically everything on the antenna. That shouldn't really, yeah, it comes out, but it's also say the impedance of this tank circuit is very low when you're off the resonant frequency. So pretty much everything other than 455 kilohertz meets up with what looks like kind of a short through here. Short. And this goes. Oh, wait, back here to this 75 volt power supply line. That's because it's going to the plate. You're not supposed to draw the RF off of this. Shouldn't there be a capacitor back to perhaps B minus here on this line? He says, inquiring to nobody. So this is the top of the power supply. Sometimes what they do with these electrolytic capacitors is they put a regular smaller non-dielectric capacitor across them, because these guys are not very good doing RF. But that appears to be missing in this radio. But that's far-fetched that the radio's designed wrong, and that's why we're having this trouble. That's a crazy thought. Isn't it? So if the signals are seeing this kind of as a short, could this just be bad alignment, like terribly, terribly bad alignment? I don't believe that either. I mean, the radio's operating. It's just weak. Maybe a terribly leaky capacitor causing that? Can we put a scope on here and see remnants? This is basically putting a scope on here and see remnants of the local oscillator right on the top of the power supply, because these capacitors aren't quelling it. They aren't showing it ground. They aren't beating the daylights out of it. So if that were the case, though, if somehow the local oscillator can get over here, its frequency is way off from the resonance in here. I think it's a sneak by. I think it's a sneak by. It's sneaking by. So the resonant frequency is 500 kilohertz, and the local oscillator is running at 1,000,000. So if it's going to sneak through, it's going to sneak through the capacitor to get to this point. Now, how does it get from here? Well, that would invite it up into here. And the local oscillator would be invited up into here, too. They'd be everywhere. I think you would have all kinds of howling and feedback and crazy stuff going along with this effect. But I've seen this before in a radio. I think it's time to get to the root of it. I'm going to put the scope on this terminal here and just see what is going on the top of this capacitor. And the reason is it's not hard to do, so I'm going to do that. Okay, so that actually hints on which one's the larger one. We want to go on the smaller one. We want to go here. Everything's fine. We should have the oscilloscope on for this, I guess. Okay, so we're on, I'm going to put it on DC. I'm going to put this up 5 volts per division, and we're going to move it down. It's going to go up 5, 10, 15, 20, 25, 30. It's going to go right off the screen. my prediction. It went right off the screen, didn't it? I can't look. Okay, yeah, right off the screen. We'll put this back on AC, and we'll put it back up in the middle. Oh, that's the wrong control there. Well, don't see much there at 5 volts. Okay, what is that? We see there, you can't see it in detail, but don't worry about it yet. I bet you. Make my guide trigger, please trigger. Never wants to trigger. Make this bigger. I'm trying to trigger on the lines, what I'm trying to do. Oh, you crazy. And my scope needs work. Now it just won't trigger at all. Okay, so I can cheat this by fooling with the speed. There we are. Okay, so what do we got there? We got a great big, well, I would say it's a big hum. Can't tell what frequency that is, but it probably is 60 cycles. It looks like rectified 60 cycles to me. So it'll actually be 120 per second of these. Okay, I'm going to tune the radio and see if we see that frequency change. No. I can see some. No, it's the same. It's the same thing. So there is a little bit of RF in there. It's going to be in here, and we're not going to be able to see it, really, except by some extraordinary luck. The luck is not on my side. There's something. Okay, now you probably can't see this at all. I'm guessing it's just a kind of a white bar. It's a varying frequency. I'm just trying to get some kind of pattern on here that. Okay, there's something. You can kind of see that there's some kind of pattern on there. Now I'm going to tune the radio and just see if that pattern goes wandering around. I would say so. Wait a minute. What happened to it? It's got a mind of its own. Okay, I'm not quite sure what I'm doing, but that's the fun of all this. Oh my gosh, that's quite a schmozzle there. I get a better pattern. That's what happens when your scope won't trigger for you. There's one there. Okay, now I'm going to tune the radio. I'm not doing anything. It's whatever it is, it's drifting around for whatever. I don't know. It's not stable enough to. Well, that's interesting. It's kind of stable there. This is an ineffectual way of doing this, I think. Well, I don't know. There, see, I got it stable. It's going to the right. I don't know. No, it's not convincing of anything. Oh boy. That was inconclusive. Another way would say, well, let's pretend there is some stuff there. The local oscillator is appearing in the B+ supply. That's basically what I'm saying. What we would do is try to drain it out. Try to drain it out by temporarily connecting a capacitor right across the power supply. So we'd get something like a 0.05. 0.05 that I'm willing to hold on to. This might do the trick. 0.05. This is probably a very high voltage capacitor here. Look down here. What I want to do is I just want to bridge it. What do I want to bridge it? And watch this. Bridge the negative to where I've got this. This to trap one lead. Take me dog. And then the other one, go right like that. Watching the voltage over yonder. Nothing happening. Nothing at all. Scope, nothing really. Nothing really happening. I don't know how true then. Is this really a 0.05 even? Do I even know that? This old capacitor. Oh my gosh. Hard time seeing that. It says 50 nanofarads. 50 nanofarads is 0.05. It's definitely what it says it is. 0.05 microfarads. Well, really kind of stumbling around here. Something terrible. Really am stumbling around. If we want to look at, so when I killed the local oscillator, the voltage went down. The local oscillator, in combination with the desired signal, provides the energy that's coming out, if I can use that term, energy. Provides the strength, or results in the strength of the signal coming out of the IF. If you reduce the local oscillator, the IF signal will also go down coming out of the IF, assuming you have something tuned in. I gotta come up with gotta come up with some way to x-ray this thing. Okay, this is getting a little bit crazy for me, but what I've done here, in fact, I'm going to take this out of here right now, so I've switched off my signal tracer. I have my SDR radio running. We're going to take a look at it in just a second. The radio itself is sitting right here. The radio antenna is connected through these. One of these is a 10-to-1 pad, and the other one is just a capacitor in here, just to be absolutely safe. Hooked up to a scope lead, but I'm not using it as a scope lead. I'm using it as the antenna lead from the SDR. Connected the ground to the B- grounding here, and I've connected this to the output of the IF, where it comes and heads for pin 5. Although this diagram is backwards. So what's on the SDR is now what is coming out of the IF. So we can take a look at it, and we can actually look for the local oscillator if it's there or not. We can just see what's going on. So let me put the SDR on the screen here. Often my SDR is just full of crap. This isn't actually as bad as from the surprisingly enough. Now the local oscillator, the radio's tuned for, where is it tuned? Tuned, well, around 700. Local oscillator's going to be 450 above 700, 1150. So we look around 1150, which is somewhere around in here. I'm going to tune the radio and I'm going to watch here for something moving. Any one of those peaks or something, anything. Right in that area. Okay, so I'm tuning. I don't see anything in that area changing at all. But there is an area on here where you see action. This is quite interesting, actually. And that's right over here. Okay, see where this red blue line is just developed right in here. What frequency is that? 455. That's the IF frequency. So we are looking at the IF output. Let me just zoom in on it. I'm going to put the radio SDR receiver line here, and then we're going to zoom in, and it didn't work quite the way I expected. We want 455. So, okay, 455 is right here now. As I tune the radio, just watch what happens there. Just going to slowly tune the radio. I'm tuning it in one direction, and you see things passing through the IF. You really, if you've never seen anything like this before, for the first time you're seeing a radio really being tuned, what's really going on. So we're mixing the local oscillator with the incoming antenna signals. They're all noise signals, I'm pretty sure. And as I increase the local oscillator frequency, I'm decreasing it as I bang the microphone there. As I decrease the local oscillator frequency, you can see, hey, that's going the wrong way. Well, what happened there? I've hit the end of the row, so let me tune way up. Way up. Go up to the other end. Is there anything funny happening? So this looks like I'm right at the other end now. Looks like a very strong noise signal there, but I can't tune further. Coming back. Okay, now you can kind of get the impression that the peak of the IF is right about there. Not 455. I'll put the red indicator right on it here. That's pretty much right on it. We can listen to that. It's a big ugly noise signal. Now I'm going to tune the radio down from there. I'm not interested in that, to where there is a signal. We know from experience, down in this area. Now, can we spot it? Is that it? A little tiny bump? Let's turn up the radio here. The radio is suppressed by the connections I've made to it. But interestingly enough, what isn't suppressed is the SDR. So I'm going to turn down the radio. I'm going to turn on the SDR sound. Can we tune something in here? Okay, so I have to rotate my... The radio antenna is exactly the wrong way. Let me turn this whole deal here. So I'm rotating the radio. The antenna's in a more favorable place. Can we pick it up a station? So that's the SDR you're listening to now. I have to go slow. There's a delay in the SDR. Okay, I'm gonna kill the speaker on the SDR. What do we hear coming out of the speaker of the radio? That's full volume too. So am I eliminating the idea that there's some amount of local oscillator appearing at this output? So where's the local oscillator right now? So we're tuned to 590. Let's call it 600. 600. You want to add 450 to 600? 1050. So we look at 1050 on here. Let me zoom out. 1050. So 1050 is right in this area. So the question is, as I tune the radio a bit, does anything move there? 1050. I don't see a thing. But I'm watching the AVC voltage behave just the way it's been behaving. So what is there here that can do this? What signal is here at being rectified by the detector? Nothing. I don't see a thing. I've tuned right back and forth across the band here. Oh, well, my theory is completely shot to pieces now. It would look like the local oscillator is simply suppressed to the point where we can't even see it at all compared to the noise that we're seeing on here. That's the way it's supposed to be. It should be suppressed right at the primary of the first IF. Okay. I'm continuing with basically no clue what's going on here. But clearly the ABC is not behaving properly. Look at that ABC capacitor again. And just double check it. Okay, gonna stop here. Okay, this is actually a fairly easy change. Just take this off here. Alright, this is the SDR. Go on here. This is the voltmeter right here. Okay, what do we see? Now? Tune the radio a little bit. I don't see a thing. I thought I'd see the local oscillator at this point. You shouldn't. There's a local oscillator happening. But I can still see the AVC voltage is doing exactly what it was doing before. Okay, why don't we get a better look at the local oscillator itself? Now that's a little tricky because the oscillators are kind of fragile in the sense that if you hook up test equipment, they stop oscillating. So we want to get from basically pin 1 of the 12BE6. Pin 1 of the 12BE6. Okay, I'm just going to leave you looking at that. The screen. I'll just tell you what I'm doing. Disconnecting the antenna. lead, and now we want to get to, what did I say? I said pin 1 of the 12BE6. Pin 1 of the 12BE6. I'm risking my SDR a little bit doing this, but I think I've got enough protection to protect it. Here we go. Ooh, hot diggity dog. There you see the local oscillator now. So very strong signal here. Now, here's some interesting stuff. Here's another one up here. Now, this could be caused by the SDR being overloaded. There's probably piles of them here. Now, if I tune the radio, I see some really weird stuff happens. Lots of weird stuff happening. Some of this is SDR stuff, but not all of it. So you see we've got a signal here at 3 megahertz. Does that signal really exist? We're going to find out. Hope you're having fun watching me. I'm just goofing around more or less, but sooner or later I'm going to hit on something. Is there really a 3 megahertz signal in this radio? Let's find out here. So we'll dial in 3 megahertz. Perhaps right there. Hard to tell. So, how accurate was this? I need to check again. Not 3. It's not 3. Oh, this is better. Tune this across here. So we'll set this to 3. Just. And now we'll tune this across it. Right there. Did you hear it? Okay, there's a similar thing up at 4 megahertz. Let's try that. Okay, they're real. Those are real signals. So your local oscillator is happily producing signals way out of the range that it's supposed to. It should be inconsequential. Although if you've got a 4 megahertz local oscillator and then you've got a noise signal at 4 plus the IF, 4 or minus the IF, one way or the other, say 4.455, this radio might tune it in. We can do this experiment right now. This radio is tuned so a local oscillator is producing a 4 megahertz signal. What happens if I pump into the antenna, and this is, pump is the word for it, a 4 megahertz plus 455. Let me turn the radio up. Oh, wow, it's producing lots of sound. 4 megahertz. Oh, no, 4.455. I don't hear a thing. So we're trying to get a 4 megahertz signal through this antenna into this tube, and it's not getting there. So the antenna circuit is tuned. It's not tuned. Oh, there's a signal. No, it's a cat calling me. Yeah, maybe I reached the end of the road here. God, I've really been swimming around in the deep end all day here. lots of stuff to think about. No solution coming. Now, I mean, if you're maybe you know exactly what's wrong with this radio. Maybe you're busily typing comments on the video. Please go ahead and do that. But just be aware, I won't be reading them. Reading comments, believe it or not, destroys this whole experience that I'm trying to have here. So it turns it into a whole different experience. So I'm not so interested in. Okay, but thank you very much. Go ahead, have a discussion in the comment area. That's fine. Just be gentle. And tomorrow I'm going to continue the crazy hunt here. Who knows where this is going to end up? I sure don't. Thanks a lot for watching.